This is Daryl with Hands-on Cisco Training, episode 25. Today we're going to give an example with two autonomous systems with eBGP and iBGP. Here's our map for today. The top router is going to be an autonomous system by itself, 65001. It's allocated 172.16.0.0/16. It's going to have two eBGP neighbors, the middle router and the bottom router. In the bottom area, we're going to have two routers inside Autonomous System 65002. It has two /16s allocated to it, 172.17.0.0/16 and 172.18.0.0/16. It's the middle and the bottom routers are going to be iBGP neighbors from their loopbacks, and each router, the middle router is going to be an eBGP neighbor with the top router, and the bottom router is going to be an eBGP neighbor with the top router. I have my IP addresses configured, but I do not have any routing protocols configured. As we learned in the last episode with iBGP, in order for the middle and we don't need an interior gateway protocol in the top autonomous system because it only has one router. However, in the bottom autonomous system, we are going to have to require an internal gateway, routing protocol, and we're going to configure OSPF again today. Let us begin. Here we are on the top router. Conf T. I don't need an iBGP. I don't need an interior gateway protocol. So I'll get straight into the router BGP commands. Router BGP 65001. No synchronization. And no auto-sum. No auto summary. And then neighbor 172.17.1.1, 285.285, I'm sorry, I need to make my neighbor, this is an eBGP neighbor, so I have to make my neighbor the physical interface. So the physical IP address that I'm neighboring with is 172.16.2.2 remote-AS 65002. And my other neighbor is neighbor 172.18.2.2 remote-AS 65002, and I want to originate the route 172.16.0.0/16. To do that, I need to meet my two conditions. So I need to type in network 172.16.0.0, and out of habit I'll type mask 255.255.0.0, although this is a class B, so the mask of /16 is assumed. And that completes my BGP configuration. If I do a show IP BGP sum, I can see that I have two neighbors configured. However, they're both in the active state, meaning they're actively retrying to connect to the remote routers. The remote routers aren't answering because I have not configured BGP on the middle and the bottom router yet. If I do a show IP BGP, I can see that I have no routes originated. And the reason I'm not originating any routes is because even though I have the network statement configured for 172.16, the second condition for originating a route is that I have to have it in my routing table. Show IP route. And I don't know how to have a route for 172.16.0.0/16. This just is like the header for this section of the route table. I only have three directly connected routes in my route table, and none of them match that. So I will configure a static hold down route. IP route 172.16.0.0, 285.285.0.0, and null 0, so the traffic will go out the null 0 interface, so it'll be dropped. So traffic destined for 172.16.0.0 will be dropped unless there's a more specific route which supersedes it, or a route which is also the /16 with an administrative distance better than what I'm going to configure, which is 254. show iBGP. And now if I show iBGP, you can see that I'm originating the network 170.16.0.0. The next hop is all zeros, which means me, and there's an asterisk here, which means that it is valid. I'm going to do a write mem today, because this configuration in this lab, when I complete it, I'm going to use this for the next couple episodes when I talk about filtering. Let's go to the middle router and configure Autonomous System 65002. Here I am in the middle router, and I don't have a routing protocol configured yet. And first, I need to get my iGP up. So conft router OSPF. I'm sorry, router OSPF process ID 1 network. In general, since I'm on an autonomous system and I don't trust remote autonomous systems, I don't want to configure OSPF on this interface. I don't want to run OSPF on this interface. So let's configure OSPF just in my internal subnet. So network 172.17.0.0 and don't care bits are 0.0.255.255 area 0. So now if I do a show IP OSPF interface, you can see I'm running OSPF on serial 0, which goes to the bottom router. I'm running OSPF on loopback 0, but I am not running OSPF on serial 1, which is good because I don't, just in case the top router, which is in a different autonomous system run by a different organization and a different group of people, just in case they accidentally configured, if they configured OSPF on that interface, then we'd talk OSPF to each other and we could really hurt each other. So, and then let me configure my BGP just so it comes up. So conft router BGP 65002, and now my standard config stuff, no synchronization, no auto -sum, and then neighbor. Generally I want to configure my iBGP neighbors first, just out of habit, because you want to get your internal network up and working before you start talking to external autonomous systems. So neighbor 172.18.1.1 remote-AS 65002 and neighbor 172.18.1.1 update-source LO0. And then now I'll configure my eBGP neighbor, which is 172.16.2.1. Neighbor 172.16.2.1 remote-AS 65001. And I don't need the update source there because for an eBGP neighbor, I want to configure with the physical interface IP address. So that completes my config on this router. I will do a write mem, and I will move to the bottom router. Here I am on the bottom router. Conft router OSPF for the process ID 1.
Oh, now I have.
Oh. Okay, router OSPF 1. Network 172.17.0.0 0.0.285.255 area 0, and then network 172.18. I want to match this loopback, but I don't want to match this serial interface. So 172.18.1.1 0.0.0.0 area 0. show IP OSPF int, and serial 0 is up. Serial 1 has, serial 0 is up, but OSPF is not enabled. Serial 1 is up and OSPF is enabled. And loopback is treated as a stub host. So the output here is a little bit different because this is an older version of iOS. Let me see if I have a neighbor, show IP OSPF neighbor. And I have the middle router is an OSPF neighbor. Let me look at my show IP route. In my show IP route, I am learning one route via OSPF, which is the loopback of the middle router. Great. Let's configure BGP. Router, BGP 65002. And then my standard config stuff, no synchronization. No auto -sum. And then what I need is I need my neighbors. I'll do my iBGP neighbor first. So neighbor 172.17.1.1 remote-AS65002. Neighbor 172.17.1.1 update-source LO0. And then I'll do my eBGP neighbor 172.18.2.1 remote-AS65001. Neighbor 172.18.2. Oh, I don't need to do the update source. Let's do a show IP BGP sum. And one of my neighbors just came up. My iBGP neighbor just came up. My eBGP neighbor is not up yet, but I just configured it, so it was still in the idle state, so it hadn't even tried yet. And now it has gone active, so it is trying to bring up the neighbor. And it is still active. Let me do a, while I'm waiting for it, show IP BGP. And you can see I have a route that I've learned in BGP 172.16.0.0 that's originated on the top router. And the next hop, this is interesting. This is something that we're learning new today. Show IP BGP. The next hop is, on that previous one, was 172.16.2.1. So now I've got this network path twice, because this means the repeat of the one above it. And I have two next hops, 172.18.2.1 and 172.16.2.1. Let's scroll back here before the new neighbor came up and look at that route. This was before this direct neighbor relationship between the top and the bottom came up. So there was a BGP neighbor relationship between the top and the middle, eBGP, and there was a BGP relationship between the middle and the bottom. So the route that was originated by the top, it made it to the middle router, and the middle router naturally would have a next hop of 172.16.2.1. Then the middle router sent me the route, and it did not change the next hop IP address. So on the bottom, on the bottom router, when I received the BGP update, it still said that the next hop to get to this route 172.16.0.0/16 was deliver the packet to 172.16.2.1. Now there's an important problem there that I want to cover, so let me shut down my other neighbor. Conft router BGP 65002 neighbor 172.18.2.1 shutdown. This is a useful command. It shuts down the BGP neighbor, but it does not erase any of the configuration. We do this sometimes in production. If a particular ISP is having problems, and like it's dropping packets or something like that, if they're, one of our ISP vendors is malfunctioning, we will shut down our BGP relationship with that neighbor and give them a call and open up a trouble ticket, and when they resolve the problem, they'll call us back, and then and only then will we know neighbor blah 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 shut down and bring the neighbor back up. So this is a useful command. But right now I'm using it to teach something. Well, neighbor 172.18.2.1. Wow, no shutdown command. This is an old version of iOS. Okay, to teach this I'm going to have to do it the other way, because I need to teach you. Actually, I can do it a different way. Conf T. So I will shut down the I will shut down the physical interface then. Int serial 0 shut. Show iBGP sum. And now my neighbor is idle. And if I do a show iBGP, I can see for the remote route 170.16.0.0, my next hop is 170.16.2.1. Let's look at that at the route table. Show IP route. And it says get there via 172.16.2.1. So 170.16.0.0/16 via 170.16.2.1. But how do I get to 170.16.2.1? There's no route entry for 172.16.2.1. In fact, a more modern version of iOS might not even put this entry in the route table. If I do a trace route, trace 172.16.7.7. Actually, let me break out of this. Control C. Conf T no IP domain dash lookup, and I do a trace 172.16.7.7, which is a trace route. It doesn't even go one hop. My router has no idea where to send this packet, because it's supposed to send the packet that matches this /16 to 172.16.2.1, but the bottom router doesn't know how to get to 172.16.2.1. Well, why not? The middle router is directly connected to this subnet. Why doesn't the bottom router know? The answer is that the middle router, when we configured OSPF on the middle router, we did not configure it on this link between the autonomous systems. So the middle router is not advertising this subnet inside our iBGP. In addition, when the middle router has an eBGP neighbor relationship and it receives a route from the other side, it says the next hop is the other neighbor, and then when it passes on that route via iBGP, it does not update the next hop. You only update the next hop when you're sending and receiving the route via eBGP. So in order for BGP to work here, in order for the bottom router and in general the entire autonomous system to be able to deliver packets to the remote autonomous system, then you need to have a route to the next hop. There are two ways to solve this problem. One way to solve this problem is to advertise this subnet safely inside your interior gateway protocol. Another way to solve that problem is to use something called next hop self. So let me do that in each case. Let's say on this one, 172.18. This subnet, because it's 172.18 address space, which belongs to the bottom autonomous system, let's go ahead and advertise this safely in OSPF. Whereas over on the middle router with this subnet, let's go ahead and do a next hop self. Okay, so here I am on the bottom router. My trace route obviously is failing. And conf T router OSPF 1, and what I want to do is I want to advertise this subnet in OSPF, but I don't want to talk OSPF on the subnet. So the way to do that is in OSPF passive interface. and I want to do a passive interface on serial 0, and then once I've done the passive interface, I can actually use a network statement to bring that subnet online. And then, so network 172.18. Making it specific as possible in this case, 2.0, 0.0.0.0.285, area 0. Now if I do a show IP OSPF int, I can see, oh, and I need to do a no shut. Conf t int serial 0, I shut it down, so I need to do a no shut on the physical interface. Show IP OSPF int. So here, serial 0 is up. It's active in it's active in OSPF, but it has no hellos because it's a passive interface. So it will never form a neighbor relationship, even if the router on the other side wants to. So now I am advertising that route inside my OSPF domain, but I'm doing it in a safe way. Okay, let me go to the middle router. Conf t, and then the next hop self, when I send, I want to configure the next hop self on the iBGP neighbor relationship. So the iBGP neighbor relationship is with neighbor set 172.18.1.1. So conf t router OSPF 65002 neighbor 172.18.1.1 Okay, I paused for a minute because on the middle router I did not see the neighbor next hop self command. I went ahead into the top router and here I see it. So if I do neighbor, the syntax is like this: neighbor 172.18.2.2 next, and I hit question mark, you can see next hop self. What that will do is on a neighbor what that will do is whenever you advertise a BGP update to a neighbor, you will make yourself the next hop when you advertise it. That is the default for eBGP. For iBGP, it is not. For normally when you're advertising, when you send an update via eBGP, you make yourself the next hop. When you send an update via iBGP, you leave the next hop unchanged. And unfortunately, the middle router is sort of a medium version of iOS, and even the medium version of iOS does not support this command. The top router is a more, it's 12.2 version of iOS, 12.2T train, so it supports the command. So I want to show you the syntax. Unfortunately, on the top router, it's not going to help us. So that means that in order to solve this problem, I'm going to have to advertise the 170.16.2.2 subnet, 2.0/24 subnet in OSPF in a safe manner. So middle router OSPF 1 passive int serial 1, and then now that I have a passive int, I can do network network 172.16. I'll show you 2.2 0.0.0.0. That'll turn it on this interface. Area 0. Show IP OSPF int.
Daddy?
Okay, so you can see the interfaces here. Serial 1 is now an OSPF active interface. However, no hellos are configured, so there is no way that a neighbor relationship will form. So now, let's look at our OSPF. Let's look at the route table, show IP route. And show IP route, and you can see I'm learning one route via BGP, 170.16.0.0/16, and I'm learning two routes via OSPF. This is in the middle router, so I'm learning the loopback route from the, so I'm learning on the bottom router, there are two routes I should learn. This link, this /24, and this /32 on the loopback. And here they are. There's that /24 link, and there's the /32. So I almost have complete routing information here. I also need to originate routes from AS65002. I'm going to go ahead and originate one of my /16s from the middle router and one of my /16s from the bottom router, and then save all my configs. So conft and router BGP 65002, network 172.17.0.0, masks 285.285.285 and then I need a hold down route. Okay, the hold down route IP route 172.17.0.0, 285.285.0.0, null 0254. Oops, exited too often. Show IP route static. Show IP BGP. And here you can see that in the BGP table I'm learning 170.16/16 and I'm originating 172.17/16. You can see the next hop is all zeros. On the 170.16 I have two different next hops. One is next hop 170.18.2.1 and one is 172.16.2.1, and BGP has chosen the second one as the best path, which makes sense because this IP address is closer to me metric-wise than this IP address. So I'll do my write mem, and then I will go to the bottom router. So bottom router, conft router BGP 65002, network 172.18.0.0, mask 285.285.0.0, and then I will put in my static hold down route so I can meet the two preconditions for originating a route in BGP. You need a network statement, and you need a route which exactly matches the route, which exactly matches the network statement. So IP route 172.18.0.0, 285.285.0.0, null 0284. Now I do a show IP BGP, or I'm sorry, I do a show IP route. I keep on meaning to do show IP BGP, and there I finally did it. And you can see now I have all three /16s in my BGP table. The one I learned from Autonomous System 65001, and there are two next hops to get there. And on this router, I've chosen the top one with the next hop 170.18.2.1 as the best one, and that makes sense because I'm on the bottom router, and this next hop is closer to me routing wise than this next hop. And then on 172.17.0.0, the next hop is the loopback address over here, which is interesting. How does the bottom router forward to this IP address? Well, it does what's called a recursive route lookup. If you do a show IP route 172.17.0.0, let me do it specific. Show IP route 172.17.0.0, 285.285.0.0. So I'm going to look up the route precisely for the /16. And you can see the next hop is 172.17.1.1. So then it does what's called a recursive route lookup. How do I get to 172.17.1.1? Show IP route 172.17.1.1, and the next hop for 172.17.1.1 is from 172.17.2.1 on serial 1. So I will output out serial 1 to 172.17.2.1. So this is just another example of how BGP, well, BGP does the recursive route lookup to get to the destination in this case, and note that the recursive route lookup used the route for the loopback, which was learned via OSPF. So that's just another example of how BGP needs to run on top of OSPF within an autonomous system. So show iBGP. So 172.17.0.0, the next hop is 172.17.2.1 or .1.1, which, even though the bottom router can't get there directly, thanks to OSPF, it knows to get to this next hop, it sends it out the serial 1 interface to this IP address. And then, of course, 170.18.0.0, which the bottom router is originating, has the next hop of all zeros, which means me. Of these 4 entries in the route table, 3 of them are best. The best are indicated by this little arrow. So this entry here, which is for 172.16.0.0, they're just not printing it out here, is, if they don't print it out, then it means the line above it. For this one, it is, this next hop is not as good. Okay, so let's look at our config and review what we've learned. Again, inside an autonomous system with multiple routers, we run iBGP in a full mesh. In this case, the full mesh is just our first router connects to the second router. So not much of a mesh, but it's still a full mesh. In order for BGP to work, we need another routing protocol so that all of our loopbacks know how to talk to each other. And so we configured OSPF. And then we configured BGP. We did our standard config stuff. We have our neighbors, our iBGP neighbors. We specify the remote AS as the same as our AS. We specify our update source loopback 0. And our eBGP neighbors we run on the physical link between the routers. And then to originate a route, we put in a network statement, and we need to have a route in our route table that exactly matches that network statement. And so in this case, we chose to put in a static hold down route. And that is how you run BGP in a network with 2 autonomous systems. In the next episode, we're going to learn how to filter routes, or rather, in the next 2 episodes, we're going to learn how to filter routes, and we're going to learn how to prefer certain paths, because that's the power of BGP. It gives you the intelligent filtering, and it lets you make policy-based routing decisions based on, for example, autonomous system number. Thank you very much.